Okay, we're back for 5.3 day 2, working on examples 6 through 9. Here on example 6, it gives us 2 sine squared x plus 3 cosine x minus 3. Notice that we have sine and cosine in the same equation, so we're going to need to change it all to sines or all to cosines. The easiest thing I see here is sine squared, and if you recall, sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared of x. So I'm going to take out sine squared of x, and I'm going to put in 1 minus cosine squared. So it gives me 2 times 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0. And I did this so I'd have one trig function in the equation and not two. Okay, one trig function in the equation and not two. Distributive property, 2 minus 2 cosine squared x, and plus 3 cosine x minus 3 equals 0. Collect like terms, negative 2 cosine squared x plus 3 cosine x. 2 minus 3 is negative 1. And then I would divide the whole equation by negative 1, so I'd have 2 cosine squared x minus 3 cosine of x plus 1 equals 0. And I did this just so the cosine squared have a positive coefficient. Now I have to go into factoring. And since it is just guess and check, I have to multiply to make 1 and add them together to make negative 3 cosine x. So 2 cosine x has to be minus 1 minus 1. And so that makes negative 1 cosine x in the middle, negative 2 cosine x on the outside for negative 3 cosine x. So I factored it, set my factors equal to 0. So 2 cosine x minus 1 equals 0, cosine x minus 1 equals 0. So the cosine of x is 1. Here I'm going to add 1 divided by 2, for cosine of x equals 1/2. Now I have to figure out what are my possible solutions. Well, for the cosine of x to be 1, the cosine is x, and so that's here, 1 comma 0, and so that answer is 0. And then for cosine of x to be 1/2, triangle, there's x adjacent over hypotenuse for 1 over 2 because it's cosine. Therefore I know that's pi over 3. Because it's a 60-degree angle, that's why it has to be pi over 3. The next thing I know that is that it's positive. For the cosine to be positive, it's quadrant 1 and 4. Therefore, for the quadrant 4 angle, it would be 2 pi minus pi over 3, which is 5 pi over 3. Okay? But notice on the original problem, there is no restriction. It doesn't say 0 to 2 pi. It's basically find all the solutions. And so it's going to be x equals 0 plus 2n pi, because we're finding this is called general form. And since we're not looking for just one answer, we got to find all the answers. Then it's also going to be x equals pi over 3 plus 2n pi, and x equals 5 pi over 3 plus 2n pi. That's how I find the rest of the answers on that. I can simplify this one because 0 plus 2n pi is just 2n pi, and there's how I find an infinite amount of answers. Put in any number you want for n, and that'll tell you an angle that's complementary, or not complementary, but it'll tell you an angle that's the same. Coterminal is the proper phrase, I think. Alright, let's go ahead and move on to example number 7 now. Example 7 tells us to solve this equation over the interval 0 to 2 pi. So we know that we're just going to look for a few answers. Again, I have cosine and sine, and I want to be able to translate that into either sine or cosine. And I know that sine squared of x plus cosine squared of x equals 1. But I don't have any squareds here. So what do? Well, I'm going to square both sides of the equation so I can have some squareds. That will make this cosine squared of x plus 2 cosine of x plus 1 equals sine squared of x. And many of you are asking right now, well, how did you get the 2 cosine of x? Well, remember that's cosine of x plus 1 times cosine of x plus 1 due distributive property. And you should be able to get cosine squared x plus 2 cosine x plus 1. Okay? Now it appears I have multiple cosines, so I'm going to want to get rid of sine. And remember that sine squared x, if I subtract cosine, is 1 minus cosine squared x. So I'm going to do substitution. Cosine squared x plus 2 cosine x plus 1 equals, put in 1 minus cosine squared of x, like that. Now I have to get it equal to 0, so I'll subtract the 1, I'll add the cosine squared of x to both sides, and I'll get 2 cosine squared of x plus 2 cosine of x, and then the 1 minus 1 cancels out, equal to 0. Common factor here is 2 cosine of x, so it's going to leave me with cosine of x plus 1 equals 0 after I factor it. Set your factors equal to 0. Solve this one by dividing by 2. Subtract 1 on the other one. I get cosine of x equals 0, and I get cosine of x equals negative 1. Well, remember cosine is x, and so negative 1 is right there, so that'd be pi. Again, cosine is x, so it'd be 0, 1 and 0, negative 1, so that'd be pi over 2 and 3 pi over 2. Now, if you recall, though, from Algebra 2 and from some of your other classes, if you have to square both sides of an equation or square root both sides of an equation to start the problem, you may have what they call the extraneous solutions. So we have to plug things back in and check, okay? And it turns out that the cosine of pi over 2 plus 1 equals the sine of pi over 2. That's putting pi over 2 into the original equation. Okay, the cosine of pi over 2 is 0, so 0 plus 1 equals the sine of pi over 2 is 1. That checks out just fine, so give that a check mark. Erase that again. And now we're going to put it in the cosine of something plus 1 equals the sine of something. Okay, so now I'm going to put in 3 pi over 2. Well, the cosine of 3 pi over 2 is 0, so 0 plus 1. The sine of 3 pi over 2 is negative 1. Well, that's not true, so we cross that one out. And now we're going to put in the pi, our third answer. Cosine of pi is x, so negative 1 plus 1 equals the sine of pi to 0. Yes, that checks out. So I have two answers over the interval 0 to 2 pi. Pi over 2 and pi. The 3 pi over 2 turned out to be extraneous. I want you guys to try number 53. Press pause, then come back and see if you're able to figure out and get it right. Okay, so for number 53, cosecant x plus cotangent x, I'm going to start by subtracting the cotangent of x. And now if I square both sides, I get cosecant squared of x equals 1 minus 2 cotangent x plus cotangent squared of x. Well, there's the formula that says cosecant squared of x is equal to 1 plus cotangent squared of x. So I just use the trig identity and substitute it in. Now I'm going to set it equal to 0. What's nice about this one is when I subtract 1, it cancels out. When I subtract cotangent squared of x from both sides, it cancels out. I'm left with 0 equals negative 2 cotangent of x. If I divide both sides by negative 2, I get cotangent of x equals 0. Well, for the cotangent of x equal to 0, now because cotangent repeats itself every pi units because the period is from 0 to pi, I'm only going to search from 0 to pi. Alright, so if 1 comma 0, 0 comma negative, or 1, then negative 1 comma 0, cotangent is x over y. So the only one that works out is up here because that's 0 over 1. So it's pi over 2. Again, up here there is no thing that says how far to take it from. And so I'm going to write my final answer as pi over 2 plus n pi because it repeats every pi units. Moving on to example 8. This is the first time we've seen something like this. This is called multiple angle. What do we mean by multiple angle? Well, there's a 3 there in front of the x. Nothing changes on how we're going to solve it until the very, very end, okay? We're still going to try to get this cosine equal to something. We're still going to use our triangle. We're still going to try to figure it out. And then we're going to put it in general form. The other thing I noticed is there is no range. It doesn't say anything about being from 0 to 2 pi over here. So I know with cosine I'm going to end up putting plus 2n pi in there somewhere at the end. So let's see how this works out here. I'm going to add 1 to both sides. 2 times the cosine 3x equals 1. Divided by 2 to get the cosine 3x equals 1/2. From here, I'm going to find out where the cosine is equal to 1/2. So x goes here. Cosine is adjacent over hypotenuse. So I know this is 60, which is the same as pi over 3. Cosine is positive in the first and the fourth. So not only is it pi over 3, it's also 5 pi over 3 for the fourth quadrant angle. And the reason, notice on the one before, I didn't use anything besides the first one I came across. But on this one, because it's cosine, I got to find first and fourth quadrant. Now, I'm going to put in the plus 2n pi thing. Because I'm looking for all the angles to equal that. But it's not x equals. This is where the 3 comes in. Because it says 3x equals, I now put a 3x here to say 3x equals that. And I also put a 3x in front of the other one to say 3x is equal to 5 pi over 3 plus 2n pi. Now I'm going to divide the whole thing by 3, and that gives me x equals pi over 3 divided by 3 is pi over 9. 2n pi divided by 3 is plus 2n pi divided by 3. Same thing over here, divide by 3, you get 5 pi over 9 plus 2n pi divided by 3. And that is how you come up with the general form of the answer, meaning all answers can come through that. See if you guys can figure out number 65. Okay, on 65, it's already in the sign 2x equals, so I'm going to go straight to drawing a triangle. Opposite, square root 3, hypotenuse 2, so that's 1. We know this is pi over 3. Since the sign is negative, I'm looking for quadrants 3 and 4. So pi over 3 in the third would be 4 pi over 3. Pi over 3 in the fourth would be 5 pi over 3. Since it's a double angle 2x, I say 2x equals 4 pi over 3 plus 2n pi. I know to add the 2n pi because there is no restriction up here at the top like we've been talking about. And 2x equals 5 pi over 3 plus 2n pi. Divide by 2 for both of them. X equals 4 pi over 6, which reduces to 2 pi over 3. The 2's cancel here, leaving plus n pi. 5 pi over 3 is now going to be 5 pi over 6. The 2's cancel, leaving plus n pi. And there's my two answers. Okay, let's go ahead and work on number 9. Example 9, excuse me. On example 9, again, I have a multiple angle. This time it includes the tangent. I'm going to subtract 3 to start out with. Then I'm going to divide by 3. Alright, for a triangle, it'd be 1 over 1, so we know this is a 45 or a pi over 4. We know tangent is negative in quadrants 2 and 4. So pi over 4 in the second quadrant is 3 pi over 4, because you have to take pi minus pi over 4. In the fourth quadrant, it's going to be 7 pi over 4, because you have to take 2 pi minus pi over 4. But again, I made a mistake there. Well, not a mistake, but because it's tangent, I really only need this one because as you can see, 3 pi over 4, if I add a whole pi, it gives me 7 pi over 4. So these two, this one, if I was going from 0 to 2 pi, I'd include both of these. But since I'm going to go for all the answers, when I do 3 pi over 4 equals, or sorry, plus n pi, if n was 1, that would give me 7 pi over 4, so this answer is included in the 3 pi over 4 plus n pi. But since it says x over 2, I say x over 2 equals, now instead of dividing by 2, I'm actually going to multiply everything by 2. And so that gives me x equals 2 times 3 is 6 pi over 4, which reduces to 3 pi over 2, plus 2n pi. And now I have the general form of my answer on example number 9. Okay, let's try one more problem. Let's try number 67. See if you can figure it out. Now this is a cosine problem, so that tells me from 0 to 2 pi the normal answers. I have nothing up here to restrict it, so I know I'm going to need to put in plus 2n pi somewhere. This is called half angle x over 2, so I know I'm going to have to do something at the end with multiplying everything by 2. But since it's already solved, draw my triangle, square root, square root of 2 here, 2 there. It looks like, what does this look like I'm actually going to do? Well, I believe if I go square root of 2 squared plus the other side squared is going to be 2 squared. So 2 plus b squared equals 4. B squared says 2, so b is the square root of 2. What that means is these two sides are exactly the same, which means this is a 45. So x is going to be pi over 4. Now, because this is positive, I need quadrant 1. Cosine is also positive in quadrant 4, so that's going to be 7 pi over 4. So I'm going to take x over 2 is going to equal pi over 4 plus 2n pi. And I'm going to take x over 2, it's going to equal 7 pi over 4 plus 2n pi. Again, I add the 2n pi because there is no restriction like on some of the other problems that said between 0 and 2 pi. Multiply everything by 2. If I take pi over 4 times 2, it's going to give me pi over 2. And that's going to give me 4n pi. And if I multiply by 2, that's going to be 7 pi over 2 plus 4n pi. And I believe those are the correct responses, and they are. Okay, that's it for today. Work on your assignment. If you forgot, it's listed under 5.3, day number 2 in the assignment folder.